Our next presentation is again from the standardization perspective, this time the IEEE perspective, and this presentation will be given by Tony Hanxiao from Huawei. Thank you, Tony.
Yeah, thank you. So let's begin. Welcome. Thank you to Professor Hank for inviting me to share some recent progress for WLAN sensing. And my name is Tony Han from Huawei Technology. Here is my outline. So we basically have 4 parts. So starting with the standard, then is the business market and Wi-Fi alliance activities, and finally the academia activities. Due to the time limitation, I will spend more time for the first part, standard part. I think we will spend more than half of the time for this first standard part. So let's begin with this one, IEEE802.11bf WLAN sensing. So I'll skip the definition. Many presenters already mentioned the definition of sensing and ASIC. The right-hand side part shows the leadership of our standard. So I will also skip that, and the timeline. So we basically formally started our standard in September 2020. But before that, we have more than 1 year preparation for the standard. And our standard will finish in next year. And right now we are in the phase of essay ballot. And we just released the draft 5.0 last week. And also we have some activities in Wi-Fi alliance. I will mention that later. And one thing I would like to mention is, our standard IEEE802.11bf WLAN sensing is the first international standard for ASIC, integrated sensing and communication. And we all know that our 6G standardization is coming, and the ASIC also being adopted as one of the 6 key scenarios. And so in the future, we have a lot to learn from each other. And this slide shows the whole picture for the IEEE802.11 standard pipelines. And you know that our task group, 802.11bf, is one task group focusing on WLAN sensing in our working group. It's here. And also you can see some familiar standard. 11X, another name for this is Wi-Fi 6. 11B, the other name is Wi-Fi 7. And 11BN, another name is Wi-Fi 8. So they are all in different phases in the standard pipeline. And this complicated table, I just want to show one information. That is, after many rounds of ballot, comments, revision, our draft is getting stable. Yeah, we are getting to the final stage of our standard. And one important topic at the beginning of our standard is the use case. So many use cases have been discussed in our standard at the beginning phase, back to 2019 and 2020. So including smart home, presence detection, gesture recognition, gaming control, vital sign, including breath, heartbeat, and so on. So a frequently asked question, and the tough question is which will be the killer application. So this is a really tough question, and I think the market in the end will show the final result. But right now I can give you some information that we already seeing in the market. We see some proprietary solution and product in the market, including presence detection, including vital sign monitoring, breath, and during the daily light or in the evening or night during the sleeping. Yeah, so that's the existing use cases which have been deployed in the market, already showing in the market. And in this slide, we would like to show one example showing the whole architecture for WLAN sensing. So I take this simple example of Wi-Fi network, typical network with one AP and a few stations, with all of them with Wi-Fi sensing capability. And assuming that the Wi-Fi sensing application is running on the AP side, okay? Then we open the AP, we can see different levels. So the first layer is the WLAN sensing application layer. So this layer basically provided the service application to the users and showing the result to the final users, and maybe optionally connect to the cloud. And the second layer is the WLAN sensing agent, the middle layer. So in this layer, we basically have the signal processing algorithm, even the AI algorithm, to process the WLAN sensing data from the lower layer, for example, the CSI, and then process this and getting the processing result, sensing result, and deliver it upward to the application layer. And this is a middle layer agent. And the bottom layer, the third layer, is the WLAN sensing radio. And this layer is our standard focusing on our standard 11bf MAC and PHY layer and features focusing on this radio layer. So this layer is basically based on our 11 standard, and it could enable the stations to, for example, handshake negotiation, set up the transmissions, and allow the actual sensor measurement to be performed, and also could exchange the sensing result, sensing feedback, and informations to each other, and also including other technology and procedures. So again, this part is the part that our standard focusing on. If we further open this part, this sensing radio part, we can have the whole picture of our standard 11bf. So basically, we have two parts. First part is WLAN sensing procedure, and the second part is the technology. For the procedure part, we can also divide this part into two categories. One is the sensing procedure for sub-7 gigahertz, and the second category is EMG sensing, is for 60 gigahertz millimeter wave sensing procedure. And if we take a closer look at this sub-7 gigahertz sensing, we have a different phase for the procedure. First one is capability exchange, just letting each other know our own capability. For example, the bandwidth, antenna, and time slot, this kind of a capability. And then is the sensor measurement session. This part is more about negotiation, handshake, to set up the transmission and sensing measurement exchange. And then is the most important part is the sensing measurement exchange. This is the part where actual sensing measurement happened. And the last one is the termination, to terminate the session explicitly or implicitly. And if we open this part, sensing measurement exchange, we have a different variant. We have a trigger-based sensing measurement exchange. This is initiated by the AP side to enable multiple stations and network sensing. And also we have a non-trigger-based sensing measurement exchange. This part is more about initiated by the station side. And also our standard could support unassociated stations to participate and even initiate some sensor measurement. And correspondingly, we have millimeter wave DMG sensing procedure, and the procedure is kind of similar as the sub-7 gigahertz procedure. And also we have different sensing types for millimeter wave, and we basically using the terminology from the radar society, For example, monostatic sensing, bistatic, multistatic sensing. Okay, and then furthermore, we have one more important procedure called sensing by proxy. This procedure is more like allowing the stations to asking the AP helping to coordinate the sensing measurement, exchange, and getting the sensing information and deliver it to the station. So it's more like a friendly for the station side, the procedure. And then talk about the technology. We have waveform sequence design. You know, we for sub 7 gigahertz, we basically reuse the ranging waveform and PBDU, you know, the sequence. And we have a signal processing and feedback. And basically, we majorly use the CSI, which is including the most part of the information we have. And also we can have some additional feedback types for millimeter wave sensing, you know, range Doppler angular map, and also the just feedback, the target, and some other informations. And for the robustness in the standard, we consider some important, capability. For example, we need to constrain the transmit power to be kind of stable in order to making the sensing procedure and feedback more stable, and also the Q matrix, you know, making this kind of a parameter constant. And also we can have some feedback about AGC or RX operation point to letting the other side know the receiver status. And also we can have some negotiation and scheduling about the sensing availability window to schedule the time duration for different sessions and different applications. And also we consider about the efficiency. We can support multiple sensing measurement sessions simultaneously. And also at the beginning of our standard, we consider about the channel model. I hear a part of the former presenter mentioned about the channel model in 3GPP. And we consider about two type of channel modeling for our standard. One is a very simple retracing based, and the other one is the hybrid channel model. It's combining the retracing based and deterministic and the stochastic, the static. So that's basically the whole picture of our standard. And the second part is about business market. This figure is provided by ABI Research in their Wi-Fi sensing business market white paper in 2022. In the future, we can clearly see the trend of the increasing trend for the WLAN sensing devices. And their analysis shows that the reason is based on the pre-standard devices, and also the official standard devices going to the market will showing the very clear trend for the increasing number of devices for WLAN sensing. And their conclusion is very clear, so promising technology and market. And some further information, some figures, similar figures showing the increasing trend. And also one few points I would like to point it out is right now we already have more than 80 ISPs already offer sensing solution to their customers. And including recently in North America, the biggest ISP also provided this application to the customers. And but right now they are only using the proprietary solutions, not the standard solutions, which have some drawbacks. For example, the uncoordinated station behavior, and cannot have interoperate from different vendors. So the standard, our 11BF standard, and also the certification in Wi-Fi Alliance will help clear the way, solve the problem of the drawbacks about the interoperability problem. So talking about the Wi-Fi lines, so this slide shows the stakeholders, 11BF, Wi-Fi lines, and their relationships. So basically, different parts in the Wi-Fi industry chain play different roles in the ecosystem. For example, chipset vendors just implement our standard in their chips, right? And also the chip vendors, the equipment vendors will, adding support of the standard based on the chip and implement the capabilities to their hardware and devices. And the software vendors, including APP and OS vendors, will cooperate with almost all the vendors, chip vendors, equipment vendors, and ISP to provide the solutions to different use cases. And the ISP will, provide the final solution to the end market and the final customers. And our standard, as I mentioned, the function is to enable the sensing function and interoperability. And the function of the Wi-Fi Alliance is to promote the sensing, Wi-Fi sensing, and also consider a certification program for selected features, in our standard to ensure the interoperability and the compliance for the chipset vendors. So that's their relationship. So when we are going, we mentioned means our standard. Our standard is going to finish. So next step is consider about a certification program to certify the standard and corresponding chipset and devices. So this picture shows the typical program development process in Wi-Fi Alliance. First step is to have a great idea which needs for certification. So correspondingly is our WLAN sensing standard. And then we need to build consensus. And we already have some initial discussion in Wi-Fi Alliance starting from last year. And the second time is this year in Austin. And the good news is we already have more than 10 members, member companies. And the next step is to socialize a proposal to form a task group. And that's my next step. Actually, the task group formation proposal will be presented next week. I will go to Spain to present this task group formation proposal in Wi-Fi Alliance. And hopefully we can form the task group maybe at the end of this year or the beginning of next year. That's the next plan. And the last part is academia things. I think some of you may already know that we found this ISAC-ETI in 2021. It's called Integrated Sensing and Communication Emerging Technology Initiative. It's the first, and right now I think it's still the largest international organization connecting academia and industry for ISAC. We have lots of members. I think right now more than 1,000 members from different society, university, and industry company. And based on this organization, we organize many activities. I only put some activities which related to Wi-Fi sensing, not broader ISAC, for example, 6G, ISAC activities. I only pick some activities more related to Wi-Fi sensing here. So first one is our first Wi-Fi sensing workshop in 2021. So this activity really kicked off the collaboration of industry, academia, and the research in Wi-Fi sensing technology. And during that workshop, we released our Wi-Fi sensing white paper. And this intention is to promote the visual building and consensus reaching of Wi-Fi sensing. And then last year, we organized the first Wi-Fi sensing contest. This one I would like to mention and emphasize one thing. So we have the track one about the detection and localization. And this one is based on our actual measured sensing datasets by real product, our real Huawei product. So we provide our data set to the competitors to do the research and the algorithm to solve the problem about the detection and localization. So finally, we attract more than 900 competitors in this context. It's far beyond our imagination at the beginning. I think the major reason is about the data set. And based on the data set, we have one more action. That is, at the beginning of this year, we launched the sensing data set platform. Actually, the date is Chinese New Year. So we launched this platform in Chinese New Year. And the intention is to provide, high quality sensing data set. I mean, the real measured data set to support AI model training and algorithm design and research in the field of sensing. And this is the first large scale actual measured sensing data set platform. And our vision is to adding AI wings to sensing. That's our vision. And hopefully this data set platform will growing bigger and providing very extensive data set to the society, including the academia and the industry. All right, I think that's basically all of my presentation. So last slide is about some picture of my friend, including some standard friend, $11bf friend, ISAC-ETI friend, and some friend from the context workshop and Wi-Fi lines. And I would like to use one last sentence to end my presentation. That sentence is from our boss, the boss of Huawei, Mr. Ren Zhenfei. It said that a cup of coffee also could be beer, absorbs cosmic energy. So let's work together to bring Wi-Fi sensing and ISAC to everyone. So that's all on my presentation. Thank you. And I'm ready to take some questions.
Thank you, Tony. And again, for the audience, please feel free to ask questions. We have one question from the audience right now. The question is, will there be other data sets from your group in addition to the one for the Wi-Fi sensing contests? Are there future plans for more data sets?
After the I think the question is from the guy who may already know our dataset and contest. So we are keeping getting some more datasets, and we are trying to put more datasets in the platform. I mean the SDP platform, and hopefully, we are attracting more and more people to contribute to the platform, and can grow up to be really useful for the society.
So maybe a follow-up question. So this last data set that you mentioned, can you elaborate a little bit more what kind of data it contains? Is it like vehicular data, or is it gesture recognition data? What kind of data?
Yeah. So this data set is more about the indoor detection and localization data. So we're using our product, for example, FTTR and the enterprise AP to connect the data. The data is actually the CSI, indoor CSI, and we also give the ground truth is the present or not of one or two people or 3 or 5 people, and also even the location of the people, and providing the CSI and corresponding the ground truth.
Okay, and this data set is the same data set as in the next slide, or these are distinct data sets?
So this context data set is only one part of the data set in the platform. And right now, I think right now we have more than 7 or more than 8 data set in the platform from different group, from some companies, from some university, including a very famous data set of VIDA from Tsinghua University, and also so right now the size is more than, I think right now is more than 300 gigabytes.
So another question, maybe going back to the very beginning of today, where we had the presentation from ETSI. So sensing is considered by ETSI, I guess, in a more 6G context, and by you in a IEEE like wireless LAN context. How different are they really? Is the system very similar? Are the considerations very similar? The challenges, the use cases, are they very similar, or are they really very different?
If I have to choose one from these two answers, I think it's kind of similar, but there are some differences. I can give some examples. For example, Wi-Fi sensing in our 802.11bf is more focusing on indoor scenarios, but cellular network is more focusing on the outdoor scenario, although they include the indoor scenario, right? So this is one thing, and the other thing is, for example, the business model. It kind of different. So there are some different points, but basically the things are very similar. They need some waveform design. They need some procedure design to incorporate this function into this existing system, Wi-Fi system or cellular system. The foundation is very similar, but there are some different points.
Right. So if you look at the business model, if I imagine like wireless LAN, I would buy a router, and then this router would have sensing capabilities, but I wouldn't, I guess, pay for every sensing session that I initiate. Well, maybe in a 6G context, you would have to charge people for every time they do sensing. So how can you provide your view on that?
So this is also one of the similar tough question. I can talk about a little bit about Wi-Fi sensing business model. So one of the business model I'm imagining is people can use the Wi-Fi sensing function even free, and the function or the device vendors can getting the benefit from other part, for example, the advertisement or something else. That is more like the business model, like the internet, not the charging the customer or end user directly. But right now, for the proprietary solution, for example, the ISP, right now the business model is charging the user directly. For example, like $10 or $20 per month,
right?
Providing some sensing application function.
Very interesting. I think with that we need to stop. Thank you, Tony, for the presentation. Interesting discussion.